Namaste student. Today we're going to see how to find HCF of two number or more than two numbers using prime factorization from or prime factorization method and long division method. So let's see here prime factorization method. So here if we'll take find the HCF of 24 and 32. So how are you going to do? So first we will find their prime factorization form. So if we'll go with the prime factorization form, we can see this one, and for 32, 2, 1, 6, and the 2, 8, and the 2, 4, and the 2, 5. Therefore, we can write here 24 as 2 to the power 3 into 3, and here 32 as 2 to the power, there will be 2 to the power 5. So now, in this case, what we're going to do to find HCF. So we can find LCM also, we'll see in the next video. So here to find HCF, therefore HCF of 24 and 32, this is the presentation, you can use this presentation, equals to, see here the common factor. Here you can see that 2 and 2 common are there. So after looking this one, you check here which is smaller power. So you can see that 3 is smaller, that means 2 to the power 3, and 2 to the power 3 means what? 3 times 2, 2 into 2 into 2, that means we'll get 8. Our answer is 8. So here what does it mean that highest common factor? Let's try to understand. This is the way to find the HCF using prime factorization method. But then a question will arise. Many students have a confusion. Still they have confusion that what is HCF? What does it mean? That means if I take the HCF factors of 24. Already we know how to find the factors of 24. That means the number which are what exactly divisor of this 24 is called factor. So here 1 is it's a 1, and then 2, 3, 4, and then if we go for 6, 8, and 12, and the last one would be 24. So these are the factors of 24 and factors of 32. Factors of 32 will go here 1, 2, 4, and there is your 16, and next is your 8 is also there. I forgot to write here, so we'll write here 8, that's 16, and 32. So if we look at here, that the common factor of common factors. So what common factor we can see here? 1 is there, that means 1 common factor. 2 is there, then 4 is there, and 8 is there. Is there any more common factor? No. Now, out of this common factor, which one is the highest? This is. So this is your HCF. So that only we need to find. So we're not using this method. We can use this also to find HCF, but they are not the form of your prime factorization method and the long division method. It will be hectic for you when it will become a bigger number. When we will take the bigger number, then it is difficult for you to use this method to get your HCF. So best method to find your HCF is long division method. We'll see the long division method. Very simple. What we're going to do, here only I'll show. So for long division method, you take which is bigger, 32. So 32 will be as your dividend. We'll keep it in the here, and 24 will be outside. So 24 1 ja 24. So here you are getting 8. So now what you will going to do, use this divisor as divided now, and continue this process till we get remainder 0. So now see here what we have done here. 24 1 ja 24, we are getting remainder 8. Now this remainder, for next step, this remainder become your divisor, and this divisor become your dividend. And now you can see that 8 3 ja 24, and this give you remainder 0. Therefore HCF of 24 32 equals to what? 8. Very simple. Now we'll go for the 3 number. we'll go for the 3 number. Like if we'll take here 18, 30 and 20, take this number. Okay, 18, 30 and 20, and you need to find HCF of this 3 number. So let's start with the prime factorization method and then we go for the long division method. So our target, what we're going to do, we'll find their prime factorization from 2, 9 to 3. So this we are getting, and for 30 to 15 and the 3, 5, and for 20 to 10 to 5. So we can write here 18 as 2 into 3 square, and 30 can be written as 2 into 3 into 5, and the last, that is 20, can be written as 2 square into 5. Now to find the HCF, that means common factor should be there. So find the common factor. You can see that 2 is common for all the 3 number, but if you can see that 3 is common for this 2 but there is no 3, and 5 is common to this 2 but there is no 5, so we cannot take 5 and 3 here, the number which have common to all the number. So here you can see that 2 is common to all. So now you need to see that which gives the smallest power. So if nothing means there is a 1, 2, 1 and 1, that means which is smaller, both are same here, so you can take any one of them, that means 2. So our HCF is 2 to the power 1, that means 2. HCF is 2. Now using long division method, how are you going to use? You take any 2 number, no problem. You can take 18 and 20 also, 30 and 20 also, or 18 and 30 also. So I'll take 18 and 20, no problem. You take any 2 number. Now 18 and 20 will choose. You need to see that which is bigger. Whichever will be the bigger, will keep it in a dividend form. So keep it here and your 18 will be here. So 18 1 ja 18, we are getting here 2, and this we can see that 2 9 ja 18. So this is your HCF for the 18 and 20. Now we'll use this HCF to 2 we have, and there's a remaining part, that is 30. So out of 2 and 30, which is bigger? 30 is bigger, so we'll keep our 30 as a dividing. Okay, now we'll divide it. We can see that 2 15 directly we are getting 30. That means this 2 is common to both of them. So we can say that therefore HCF of 18 20 30 is your 2. Okay, so we take one more number. So let's see here, like if I'll go for 60 and your 72, like this type of number, and we need to find your HCF. So how are you going to do? So take 60 here and 72 here. So 61 just 60, so we are getting 12, or directly again we are getting here 60, 12 5 ja 60 we are getting, and remainder is 0. Therefore HCF of 60 and 72 is what? 12. You take other number like 10 and 35, you can go 10 and 35. So in this case, what is smaller? 10 is smaller, so we'll keep it here. 10 3 ja 30, we are getting 5 5 10, and here 5 2 ja 10, remainder 0. That means therefore HCF is 5. This is your answer. So here this is the presentation for your HCF using long division method and Prime Factorization method. Hope it's clear. Thank you.